Okay. So what we're doing today is we are doing multi-step inequalities. So guys, do y'all remember multi-step equations?
Yes.
Same rules apply, okay? Same rules apply. The only thing that's going to be weird, once again, is if you multiply or divide by a negative, what do we do with the inequality? We flip it. That's the only rule that's still applying here. But I know you guys can solve multi-step inequalities because I know you guys can solve multi-step equations. All right, Darwin, when you with me?
Yes.
Hi. Okay. All right. So if you guys look at example 1. It's 13 minus 11D is greater than or equal to 79. Okay, so again, this right here is just a two-step inequality. We want to get the variable by itself, so they subtracted 13 first and divided by negative 11. Since they divided by negative 11, what had to happen? They flipped the sign. What sign are we talking about when we say flip the sign? Well, that is a really messed up highlighter. Thank you, whoever used it. Probably my pre-algebra. All right, so we had to flip the inequality here. So it was greater than or equal to. Now it's less than or equal to. Okay? And then remember, we've got to put it in set builder notation. So for the set of all numbers D, such that D is less than or equal to negative 6. And now we want to graph it. What's the number that has to be on our graph? Negative 6. Are we going to have an open or a closed dot?
Open.
Closed. Why?
Because it's greater than
It's equal to. Remember, since it's a line underneath, it's equal to, so we have to have a closed dot because it means we're including this negative 6 in our solution. Negative 6 would work. And where are the values that D are less than negative 6? To the left. Less than is always going to be to the left. Okay, because you got negative 10 down here. Negative 10 is less than negative 6. Okay, any questions on graphing? Do we need to write down our dot rules again?
Yeah.
Okay. Open, closed. So it's going to be less than or greater than. Less than, equal to, greater than, equal to. It's only when it's equal to we close that dot in.
Okay.
And if it's not.
Oh. For some reason.
Okay. Good?
Yeah.
All right, so let's do our first practice problem. We have 23 is greater than or equal to 10 minus 2W. We want to get W by itself. What do we want to move first?
10.
Okay, good. How do I move this 10? Good. Minus 10 on both sides. 23 minus 10 leaves us with 13. Does my sign change yet? My inequality? No, so I'm going to keep it the same. Good. And we're left with that negative 2W. Okay, don't lose that minus sign. All right, now Gavin, what are you telling me to do? Good. Divide by negative 2. Since I am dividing by a negative number,
That becomes negative right there.
it does become negative. What's negative 13 divided by 2?
You mean positive?
Positive 13 divided by negative 2. Thank you. Okay, negative 6.5. I will either take the fraction or I will take negative 6.5. I'm fine with either one of those. What do y'all prefer right now?
We can use decimal.
Yeah, I'll let you use 0.5. It's not a repeating decimal. I'll take it. Y'all want to use the decimal?
Yes, please.
Okay. Negative 6.5. Since we divided by a negative, less than or equal to, very good. Less than or equal to W. Okay. Now, hang on. Let's put this in set builder notation. So that means we've got to do our brackets. What's our variable? W. And then we do that line. So such that W has to come first. So if W is coming first, okay, are y'all okay with how I'm getting that?
Yes.
I'm just kind of writing it backwards. W has to come first, and W is greater than or equal to negative 6.5. Very good. It's trying to eat the W. We want it to keep eating the W. Okay. All right, so we're okay with this right here.
So it has to be 6.
Ethan, are you okay with this right here? Okay. All right, so if we want to graph it, what is the number that has to be on our graph? Careful. 6.5? Negative 6.5. Thank you very much. And is this going to be an open or a closed dot?
Closed.
Closed. Why?
Because it's included.
Do you want me to sharpen it? Okay, and is that what's making the noise? Okay. I will sharpen your pencil. Would you like to bring it? You can kind of see it. You can use this pencil sharpener if you would like.
Very broken.
Yeah, well, when you teach middle schoolers, every pencil sharpener you have is always going to be broken. Right. If W is greater than or equal to negative 6.5, where are the numbers that are greater than this? To the right. Greater is always to the right because 0 is greater than 6.5, negative 6.5, and it's over here to the right. Okay? Are we good? Questions?
That's a big problem.
It's a big problem. It is a big problem, yeah.
So we're going to have to do
Okay.
things like
All right. So example number 2 is a little bit more fun. It's easy. It's all the skills we've talked about earlier this year. So we did this in first 9 weeks. The only thing difference is instead of an equal sign, it's an inequality, but all the same rules apply. If we have a multi-step equation that's really big, what do we have to do first? Distribute. We've got to distribute first. Okay, so here we're going to keep 6c the same. 3 times 2 is 6. Minus 3 times c is 3c. Okay, so all I've done is distributed here. Inequalities stayed the same. This side stayed the same. Noah?
Yes.
All right, after we distribute, then what do we have to
we
do?
have to add the numbers that are in the same time.
Good, so we got to combine like terms. So remember that foldable we made where we did distribute? Y'all made it with Miss Nichols.
Yeah.
And then your second thing was to combine like terms. Okay, so we had to distribute first, then combine like terms, and so that's what we're doing here. We distributed the 3, and then we've got to combine like terms. 6c minus 3c gives us 3c. 6 minus 3 is 3. Okay? Then we have variables on both sides, so now we've got to move variables to one side. Hopefully this is all. Okay. Yeah, you do opposite operations when they're on opposite sides. All right, so distribute, combine like terms, move variables to one side. I'm going to go ahead and write move constants to one side, other side. If you don't remember these steps, please write them down. Y'all should really only need the first 3 because after you move variables to one side, you should have a 2-step or less equation. Okay? And y'all are writing, so I'm assuming y'all are writing this down. Oh, okay. Alright. So y'all ready to just practice one?
Yes.
Okay. Alright, so let's just go ahead and do the practice problem. It's not as intense. Alright, so we have negative 2, parentheses, 3x minus 6, close parentheses, plus 2x is greater than 8. What do we have to do first? Distribute. What's negative 2 times 3x? Good. Negative 2 times a minus 6 is a... Careful. Positive 12. Since it's a negative 2 and a minus 6, a minus and a minus make a plus. This 2x is outside the parentheses, so we just drop it down. Do I change my inequality?
Nope.
Nope, stays the same, and I drop that 8 down as well. Okay. Then we're going to combine our like terms. What are the like terms on the left side? The x's. So negative 6x and a plus 2x. What's negative 6 plus 2? Good. Negative 4x. That 12 just drops down. Our inequality stays the same, and 8 drops down. And y'all, we're at a 2-step at this point. So now what?
Minus 12.
Good. Minus 12, minus 12. Negative 4x is greater than what? Negative 4. Took y'all a while. And now we divide both sides by? Careful. Negative 4. And since we divide by a negative, what happens? It does become a positive 1, but what happens to our inequality? It's going to be flipped. Okay, and we want to write this in set builder notation. So x such that x is less than 1. So what's a number x could be? 0. Can x be 1? No. It's only less than. Very good. Y'all have any questions on this, or y'all good?
Does that
we
mean
have
I
to
can
put
be
on-
like negative 100?
Huh?
Does that mean I can be negative 100?
Yes.
Do we have to put on a number line if it doesn't say so?
No.
Do we have like the calculation?